Hey, Chet, Chupa thingy. I like it. It's got a nice ring to it. Okay. RB, yeah, come up here real quick. I gotta talk to you. Just kidding. Sorry. I knew that was coming. You knew this was coming, Pete. Alright. Let's jump into some space news, and then we got missions to fly with the SSTO, guys. So, EJ's Space and Rocket Review. I'll be back playing Starbase tomorrow. I want to pad some cash, so I think we'll do some mining. And then, yeah, we'll do some mining, get a little bit more cash, and then we'll work on the, what's the name of the ship that we have? We'll work on that. Cool. So I'm going to start my space news segment. It's a segment during the day where we talk about what's going on in the space program. And I nerd the hell out. Yep, that's pretty much it. I'll be back in about 15 minutes. Still got plenty of stream left. I'll be back in exactly 12 fagizzies. Okay? See? Look. Fagizzies. As in, where the fagizzy. See? I'll be back. Don't go anywhere. I assume yesterday's landing was perfect. Yeah, Vasia, the SSTO's back on the ground. I was actually getting it ready to launch another mission last night. We were going to launch a mission, and then the pad did something weird. But other than that, we're good. Yeah, I'll be back in a second. My big, you don't know what a fugazi is? As in, where the fugazi? Where the fugazi? Did you see that the fagawi bird? As in, where the fagawi? Did you see that part? No. Where the fugazies? I'll be back in 12 fugazies. Can this make it into today's space news? No. What does this tell us, Shio? I think you just wanted an excuse to weeb out. Lassie, okay, I got yours. Ah, Rakieta nositel Soyuz 2-1B. Moving all the space news links over. Parametry constructor racket and nositel normal. Alright. Don't Google Fagizzy. You don't need to do that. Okay. Anyway, here we go. Welcome to Space News. Our space news today begins with something that has nothing to do with space. Here you go. I could do that if I felt like it. Yeah! Yeah! Wait a minute. Yeah, alright, here we go, ready? Sorry. My bad. Okay, are they programmed for these obstacles, or are they figuring them out as they go? I think they're programmed for them. I don't think it's self-aware. I don't think it's self-aware. No, it's definitely. I'm pretty sure that's a pre-programmed routine. I think Boston Dynamics, John, is focusing more on the dexterity, but they do have robots that work automatically and interact with their environment. All right, Boston Dynamics. All right, let's see what we got.
Atlas is the culmination of over a decade of hydraulic humanoid robotics work at Boston Dynamics. Atlas stands about 5 feet tall, weighs about 190 pounds, It's battery powered and hydraulically actuated with 28.
Scott looks like he lives in Concord.
It has RGB cameras and depth sensors, which provide input to its control system.
Bro, that space frame on the back, though.
Computation required for control, perception, and estimation happens on
Oh,
board
dude, look at that.
computers.
It is,
At a practical
to an
level,
extent, it's neural net.
It's a platform for
Did
us
you
to
see
do
that?
R&D on. And as an Atlas team, we're encouraged to push, that platform to its
Look,
limits.
look.
Do the most crazy.
It looks like it's
exciting,
using LiDAR.
High power stuff we can do with it. And so we're always expanding and pushing the limits of Atlas's capabilities. And then, hopefully by extension, extending the
Maybe some
capabilities of the
mocap in
company
there,
as
too.
well at the same time.
Parkour is a useful organizing activity for our team
Yes,
because it
we
highlights
can do that,
several
Brett.
challenges that we believe to be important. First, how do we build a high power density mobile robot that's capable of extended athletic behavior? How do we design control algorithms that can create a variety of behaviors and control them robustly? And how do we connect perception to action in a way that both captures long-term goals like getting from point A to point B and short-term dynamic goals like adjusting footsteps and applying corrective forces to maintain balance?
What makes Parkour Mountain hard was not so much the individual moves. Those had been worked on a lot prior to kind of pulling together. But running the entire
Sick.
course, doing it in one contiguous set of operations, really drives the need for reliability and repeatability. And these are things that are pragmatic, but really difficult. And that's what the team really focused on. I think the biggest success is being able to show all of those exciting things pulled together and done repeatably and reliably.
It can be frustrating
Oh,
sometimes.
broken
Robots
leg.
crash a lot. It's not.
Popped the
robot
hydraulic
just
line.
Magically
Did you see it?
deciding to do parkour.
It had an
It's a
embolism.
choreographed
Oh!
routine, much like a skateboard video or a parkour
like me.
video where it's an
Dude.
athlete that's practiced his moves dozens or hundreds
That's
of
awesome.
times even to get to that that high
Oh,
level.
even when it fails, it looks right.
So we're kind of doing the same thing here with Atlas. We're exploring how to push it to its limits, sometimes operating at those limits. And we learn a lot from that in terms of how to build robots that can survive falling on their face and getting back up and doing it again. We also learn a lot about the behavior, the control, the thing that puts one foot in front of the other.
These videos are a true team
Yes.
effort. First, of course, we have the software team who is responsible for creating all the behaviors and control software required to execute the behaviors reliably on the robot. We have a hardware team who's responsible for making strategic
That's
upgrades to our
cool.
robots
Look at that. Oh,
enable
that's sick.
things like extended dance and parkour routines. Our technicians debug and repair a variety of issues that can range from broken mechanical parts to hydraulic leakages to electrical failures. And our operations staff is responsible for building these environments and repairing them when robots crash.
Hang on one second.
And our operations staff is responsible.
Humans defeating the robot empire. 2027. Colorized.
Discovery, go at throttle up.
Is that an engine crane? That's an engine crane. Okay. It's a modified engine hoist, RB. It definitely is. Actually, it looks like it was custom made. I mean, you could probably hoist an engine with it. I guarantee you that thing is super freaking heavy.
Responsible for building these environments and repairing them when robots crash through them and helping us run the many, many tests required to get this kind of a demonstration to a high degree of reliability.
Yeah, that's broken. Hey Tom, can you grab me a flathead?
Yep.
Flathead?
Gotta do it.
Flathead?
Is to get him back out on the floor and working again. Sometimes it looks disastrous and we're like, oh, we've seen this before and we can fix it so easily. And then sometimes we end up with something that looks benign and it
Go
will take
socks.
days to get down to a root cause and figure it out and then repair it. It's a balancing act between, getting down to root causes, improving designs, and
That must be such a
the
pain in
robots
the butt with
running
that
around
thing.
out on the floor. Okay, nothing looks out of the ordinary. Right?
I don't know, Sushio. We have ways of making you talk. Hey, Nico, what's going on?
The most rewarding thing about my job is that I never have to work very hard to explain.
The overhead pulley.
I love working on robots. I love working with people that have passion to push, to try new things, and really just explore things that have been unexplored. And I think almost every day at Boston Dynamics involves elements of that.
The work that we're doing now, I view as really just foundation building. We're building the core capabilities that we think any useful robot will need. And in doing so, we're really defining the next set of challenges that we're going to be working on over the next 2 to 5 years.
It's extremely hard, but it's also very rewarding. You know,
Yay!
It's like I wouldn't want to be somewhere where I'm not working on like a super hard problem that nobody else is working on. So, you know, it's just that's the opportunity that we get to do here. every
Hell
day.
yeah.
3, 2, 1.
Cool. Yeah, that guy right there, that guy at the end, Gundam expert. I mean, he invented Gundams probably in Japan, so, you know, that's why they have him there, too. It was funny. You laughed. Don't lie. Imagine those things running up Everest to save some poor schmuck in a tent with frostbite over. Yeah, dude, they're pretty. I mean, it's pretty cool. Toronto, what with that thing? What I'm thinking about, is, you know, so they're hydraulic. It's hydraulic. It's an electrohydraulic system, which means they have some kind of proportioning mechanism in there to get the robot to do stuff like this. I mean, even doing something, like, I know it's got a nub on its hand, right? So even doing a complex kinematic movement like this is still controlling a lot of different hydraulics in real time. The fact that they can have that type of electromechanical control over it is pretty fascinating stuff. It's pretty crazy, man. Like, you know, like, I thought it was electric motors. I'll be honest with you, because, like, when it's walking around, it's going... But what you're hearing is hydraulic fluid being pushed around.
Discovery, go at throttle up.
It's crazy. That's the turbo pump. Yeah, right? I think humans are still a lot more energy efficient. It's going to take us some time to come up to do enough iterations, Ando, to get to the block that humans are on currently. We're on like block 2.3 million or something. Yeah, it's going to take some time. Play 27-month resub. I'm not wrong to want to drop a nuke on their lab, am I? No, it's a little weird. I'm always amazed at these robotics guys. I have enough trouble getting my 3D printer not to print out a plastic spaghetti mess. I know what you mean. Yeah, very good at iterative design. I agree. Yeah, Rathing, it's Terminator, man. Dun 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 dun. Dun 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 dun. Ba-na-na-na-na-na. Now listen to me very carefully. Terminator or Detroit Become Human? Hi, my name is Connor. I'm the android sent by Cyberlife. Huh. Anyway. From their site, Atlas has one of the world's most compact hydraulic systems. A custom battery valves and a compact hydraulic power unit enable Atlas to deliver high power to any of its 28 hydraulic joints for impressive feats of mobility. That's pretty cool. I'd like to see the hydraulic system core. That's what's the most fascinating to me. I've seen how this ends. I'm not a battery. My CPU is a neural net processor. Learning computer. Cyberdyne Systems Model 101. Boston Dynamics VFT when? I mean, Bram, that is quite literally up the street from me. Yeah, 5-minute drive? Yeah, I don't live that far away. Listen very careful. Is that the Kermit the Frog one? It's the Kermit the Frog one, isn't it? Oh. Yeah, I don't understand what that is. Anyway. Pick of the 3D printed feet and torso. That's pretty insane. Did you catch a doubleheader yesterday? No, I didn't. No, JSpeed, I haven't. Anyway, let's get back into space news. So, here's the next bit of news. Nice, silly. That's awesome. So, teams at NASA Kennedy have successfully stacked the mass simulator for Orion. The mass simulator for Orion, or MSO, on top of the Orion's stage adapter OSA structural testing article on the SLS in the vehicle assembly building. Okay. So we have the mass simulator on top. And almost ready. Say SLS 3 times and you'll summon Eric Berger to the chat. It's 1 billion. No, it's 1.5. No, it's $2 billion. $2 billion a launch. Yep. 2 billion. No, it could, guys, my source told me that it could cost up to $80 bajillion a launch. Source, a guy I know. That's awesome. So, this is still pretty on track here. They have to get the Orion stage. I think they have the fake stage adapter on there right now. If they don't, and that's the real one up there, then yeah, it's just doing a mass simulator test, taking that thing off, putting the real one on, and then we're good to go. Source, dude, trust me, bro. Dish, I heard from a guy that SLS is going to cost $80 billion. Heard they're Boeing bad, am I right? Just spare me. Here, look at this picture. Well, I heard it was going to cost 30 bajillion. I heard it's going to cost monopoly money. It's like, okay. It's pretty cool. You can see in this picture that the ICPSU, the interim cryogenic propulsion stage umbilical is attached. See it right there? That's the hydrogen and oxygen lines for the ICPS. This thing that has the American flag on it right there. Look closer. Look more closelier. Oh, that's tits. 80 quintillion, shibillion, fabaloo, million yen. Okay, this looks like the, that does not look like the final OSA, the Orion stage adapter. I think the other one is down at the Kennedy Space Center processing facility, being worked on. I think that's a structural testing article. You can see that the patch on the side. You can just tell what's structural and what's like a testing article and what's not. Just because like it doesn't look like the rest of the spacecraft. You know, see how that's like gray? It's the fake stage adapter that will be removed after modal testing is done. Yeah, that's what I thought. Cool though. That's a real upper stage, which is pretty gnarly. That's pretty cool. I mean, the crazy part about this, and this is the part that blows my mind. You know, you can see all these gantries. Like you see stuff that you know. Like there's a toolbox, a couple of office chairs right there. There's a computer over there. You know, a couple of little bits of scaffolding here and there, no big deal, right? And then you realize that you're like 300 feet up in the air. Yeah, this platform here is actually not 300. It's about 250 feet up. Yeah, about that. Yeah, about that. Crew access arm should be over there somewhere. There's the Orion service module umbilical right there. Where's the vehicle stabilizer? The VSS should be attached. Vehicle stabilization system. It's literally just a bracket that holds this thing in place. One arm. Ah, yes. Let's take a look here. Wish we could have seen this live. Yeah, me too. So this is the core stage. Jeez, man. Core stage hydrogen vent line, from what I can tell. And another angle. Man, them pictures, though. These pictures are sick, dude. Thomas, you know what's just weird to me? I've stood right there. Like I've stood right there. That's weird, man. That's bizarre. That's just bizarre. No need to flex. It's just very surreal, to be honest with you. It's just weird. What SSTO are you going to build? Valerio, I've built a Venture Star. Venture Star and the X-33. So, vertical takeoff, horizontal landing, lifting body vehicle. Yep. Yeah, there it goes. Yeah, look, see? Pulleys and a weight, and I pull the umbilical away. That's really cool. Vertical takeoff, horizontal landing. Horizontal landing. It takes off like the space shuttle, so it takes off going like this, and it comes in and lands like an airplane. Cool. These pictures are sweet. It's just crazy to me that, you know, you're working on this floor, right? Like, a bunch of guys back there, got a bunch of technicians, got a bunch of snap-on toolboxes, right? No problem. And then if you look down right here, there's about, like a 250-foot drop. You're 25 stories up right now, which is weird. That's strange. Cool, but strange. Tropical Storm Henry, nuke it. That's peculiar. All right, cool. So SLS is pretty much almost done to being fully stacked. Once they fully stack it, they're gonna send it out to the pad, do a wet dress rehearsal, probably bring it back, check everything, make sure everything's good, and then send it. That's gonna take a little bit of time, though. From what I can tell here, SLS is looking probably like November, December for a launch. Yeah. I think it's net November right now. They still got a little bit of testing that they need to figure out to get this thing to fly correctly. Cities this week? I don't know, Kyle. Maybe. Starbase is really fun. Anyway. So, Swishy, alright, let's see what this JAXA activity report is. Alright, let's see. The H3 rocket. The JAXA report. Alright, let's see what we got.
On December 6th, 2020, the asteroid explorer Hayabusa 2 released the capsule containing samples from Ryugu and changed its trajectory
this is
to
really
break away
old
from the
news.
geosphere, heading toward its next destination, the asteroid 1998 KY26. The released capsule landed in Woomera, South Australia, where it was collected by the recovery team. A gas analysis conducted before the capsule was transported to Japan found that the sample container held 5.4 grams of sample.
Oh, nice, a
far
UH-1Y.
exceeding the targeted amount of 0.1 grams. Further analysis is expected to discover a wealth of new knowledge. The re-entry capsule was exhibited at the Sagamihara City Museum and the National Museum of Nature and Science in Ueno, Tokyo.
Ueno.
It will continue on a national tour in the coming months. The laser-utilizing communication system, Lucas, aboard an optical data relay satellite launched by the H-2A F-43 launch vehicle, has been activated normally after injection into a geostationary orbit. After the checkout of equipment operation is completed, the Lucas will enter into the nominal operation phase. Optical signals were successfully captured and tracked between the Lucas and the optical ground station, 40,000 kilometers apart, which confirmed the establishment of a bidirectional optical link. Taking advantage of its capacity to transmit large volumes of data immediately on a wide scale, JAXA will aim for practical use of Lucas as a core of the high-speed space communication network that support the digital society from space.
Ah, yes.
The production and testing of the first H-3 launch vehicle was completed at the Tobishima plant of Mitsubishi Heavy Industries.
Yep.
Afterward, the
My
rocket
Vic
was
just kicked in.
transported to the Tanegashima Space Center for its final
Tanegashima.
phase of development. On March 17th and 18th, 2021, the wet dress rehearsal was conducted. Mounted on the movable launcher, this 63-meter rocket was transported from the vehicle assembly building to the launch pad, fueled with liquid propellant, then underwent a countdown rehearsal for launch. The H-3 launch vehicle is
We'll get to that in
slated
a
for its
second,
maiden
Thomas.
flight by the end of the current fiscal year.
Cool.
Astronaut Noguchi Soichi's stay on the ISS lasted from November 2020 and enabled him to conduct several important missions. On March 5th,
Noguchi-san.
2021, he engaged in extravehicular activity, or EVA, for the 4th time, more than any other Japanese astronaut. On April 23rd,
Hoshide-sama.
2021, astronaut Hoshide Akihiko arrived on the ISS, ferried by the Crew Dragon spacecraft Crew 2. This occasion marked the first time that the ISS carried more than one long-stay Japanese crew member. Astronaut Hoshide was appointed an ISS commander, becoming the second Japanese to serve in this capacity after Wakata Koichi. Hoshide will be leading the cruise for 5 months. Astronaut Noguchi completed his 166-day stay on the ISS and returned to the Earth on May 2nd, 2021. Furthermore, with astronauts Wakata Koichi and Furukawa Satoshi also scheduled for long-duration missions on the ISS in
Wakata-san.
or after 2022, we have more to look forward to from our Japanese
Furukawa-sama.
astronauts. From planetary exploration, space transportation, Earth observation, and aviation technology
what's that?
to human space
Wait, what's this?
technology,
What is
JAXA
this?
will
What's
continue
that?
To meet new challenges in the arena
You didn't
of
talk
aerospace.
about that. You didn't talk about that. What did I miss something? What is this? What is the... Yeah, I made that in Kerbal the other day. What the heck? What is it? It's a wind tunnel test article. But it's interesting because they're testing lateral winds on it. So it's the vehicle's pitched up in the wind tunnel and then pitched over. So they're trying to hit air. They're trying to get laminar flow to hit it sideways, which is strange. Either that or it could just be tilted for the picture. I don't know. Either way. Yeah, I mean, it's a little bit of an outdated update, but still pretty cool. Okay. So while we're overseas right now, upcoming Rocket Lab launch probably delayed due to lockdowns. Yep.
Discovery, go at throttle up.
I've heard this record before. Here, watch this video. Can we change the music? I know this music. Let's change the beat. So this is a Soyuz 21B with OneWeb satellites aboard, and it's moving to the launch pad at Baikonur. You sound like a big choo-choo train. Hey, Riv. 4 months. Baby sub, but glad I found you. Hey, thanks. I don't know, Swishio, maybe. Watch EJ get distracted by this. I want it. I want it. I don't. Okay. Alright, so let's see. Vostok. East? Yep, that's Baikonur. Quite literally in the middle of nothing. There's another launch pad over there. Long ways away, though. Yep, watch. That will fold down, and then it'll press. It presses in, and then whoop. What's that umbilical going to the payload part? HVAC. Keeps the thing cold, or keeps the thing cool. It's literally an air conditioner. It gets hot out there at Baikonur, or cold in the summer. I mean, or cold in the winter. Excuse me. You don't want the thing to overheat and fry itself. It's designed to work in a vacuum. Stuff that's usually designed to work in the vacuum ain't designed to work down here very well. Yeah, Riv, I was working with that today. Very nice. Yeah, I don't know, Bobby. There's covers inside of the motors. They gotta remove these red covers. Wow, that was the actual audio? Really? Why do they have exposed interstages? The Soyuz has an exposed second to third stage because it hot stages for tankology. Long story short, the second stage fires for like a split second while it's still attached to the first stage. It solves a problem that rockets have called, well, tankology. How does that, what does that work? How does that work? Magnets. Basically, when your rocket's going up into the vacuum, if you shut the rocket motor off, right? Because you're going fast enough, right? The propellants will just kind of float around all over the place, right? They'll float around everywhere. You need the propellants to be at the bottom. Now, when the rocket's down here, that's not a problem, right? Because gravity is pushing the propellants down so you can start the engines. Basically need all the propellants to be, the liquid fuel and the oxidizer, they need to be at the bottom of the tank so they can go into the rocket motors. So what the Russians do is basically they have the second stage going, and then the second stage is going, and then the third stage fires its engines, and then it separates. That way the rocket stays under constant acceleration. Once again, it's called tankology. Yeah, they need that gas to go somewhere, which is why the interstage is just a bunch of struts. Look, dude, look at it. It's like, that's crazy. Now, the next thing that they should do is move the twin... Oh, no, they're going to put the hold down points. This is the hold down points. Soyuz is, like, held from the middle of the second stage. And then the rotating service structures, the twin RSS, should move up and encapsulate the rocket. Older Soyuz pads have this design on them, right? Newer Soyuz pads have a mobile service tower, basically a building that, like a mobile hangar that they could just slide over the rocket. This is an older pad design here. Transporter will release, right? Now that Soyuz is docked, and this thing should go back down and it should drive away. Soyuz is hooked into the pad. Yes, Halo, something like that. Yeah, that's about right. Good. Yeah. It's called hot staging. Yeah. Now, how like Falcon 9 would do it? Falcon 9, the Falcon 9 has a pneumatic push rod on it. And the pneumatic push rod actually pushes the stage away from the first stage, and that settles the propellants. Yeah. Pretty crazy. Oh, bringing up the rotating surface structures. Is this a rotating pad? This pad can rotate, but a 2-1B does not need to rotate, I'm pretty sure. Is that where it just stops? It's actually 4 push rods on Falcon 9. Yeah, it's actually 4. It's 3 on the outside, 1 in the center. Yeah, Thomas, I get it. That center one is not pushing it away. It's keeping it aligned. Nice try, though. Nice try. Listen next time. Now, the one in the center is just keeping the stage centered. The ones on the outside, on the hold downs, that actually pushes it away. Look it up, bro. Bruh? Bruh? Think you're gonna get me? Huh? Mother trucker? Next news. What did I just come back to? The upper stage of the Arianespace Ariane 5 rocket will launch the NASA James Webb Telescope later this year. Oh, there it is. That just left me more confused than anything. Good! Good! Oh, man. Hey, where's Frank? Frank? That's the James Webb Space Telescope's upper stage, Boris. James Webb is much bigger than this. Why is an ESA vehicle launching a NASA telescope? Because that's their contribution to the program for being able to use the satellite. They provided the launch for nothing. Would that trailer be airtight and temperature controlled? Yep. What would involve moving a payload? Yeah, you have to keep it. You have to keep the payload cool. There are electronics, and no, it does not have its radiator open. And yes, you have to keep it powered. So that trailer has power, HVAC, and it's airtight to prevent foreign object debris. If anything, it's probably actually it's not probably airtight. What they do is they don't make them airtight. They give them positive pressure. So the HVAC system is blowing in there, and it's creating positive pressure, and then they have vent holes, and the vent holes are there's a draft basically, like you'd have a draft in a building. That's what they do. They maintain positive pressure inside, so if any dust or anything tries to go in, it just gets blown away. That's actually better than keeping it airtight. That's how most things work, because they got to keep circulating the air. One more Russian news. Cam, I don't know if we can believe those TASS guys. They're, TASS might as well be Dmitry Rogozin's mouthpiece. This is a joke. All right. I don't know if we can believe those guys. The Angara launch vehicle was delivered to Plesetsk before continuing flight tests. Yep, TASS Rogozin, second account. Yep, that's right. That's right. I don't know if we can believe them. So you guys are laughing, and you realize that I'm making a joke, but then you realize that that actually happened. Yeah. Kim, I don't know about those dang old Nauka thrusters. Maybe you're trying to sabotage the ISS. I know from a guy. A guy told me that. Let's see. The train with the Angara A5 launch vehicle arrived in Plesetsk. This was reported to TASS on Friday by a source in the Space and Rockets. TASS? No! No! Stop it! Dmitry just gave you a phone call, didn't he? I know better. I know better than you about your country and how it works, right? Like, that's how this works. The Angara A5 heavy launch vehicle has arrived at the Plesetsk Cosmodrome, the agency's interlocutor. I need that as my job title, please. The launch vehicle blocks are currently being unloaded for Angara at Plesetsk. Angara is a family of Russian launch vehicles ranging from light to heavy. The Angara Universal Rocket Assemblies are manufactured at Omsk, BO Putin, part of the Khrunichev Center of the Roscosmos State Corporation. The new family uses environmentally friendly fuel components. First two launches of the heavy Angara rocket took place on December 23, 2014 and December 14, 2020 from Plesetsk. In June, Roscosmos CEO Dmitry see, I knew it. All right. Said in an interview with TASS that 4 Angara launch vehicles would be commissioned by the end of the year, but not all of them are planned to be launched by January 2022. Later on in the radio show Komsomolskaya Pravda. Got you. He noted that work was underway to send another heavy Angara rocket from the Khrunichev Center for preparation for flight tests. Okay. Okay. Compared to Proton, it's spewing rainbows and butterflies. Fair. Fair point. Okay. So. Interlocutus of the Borg. Yeah. All right, next thing here. The SS Ellison Onizuka arrived at the ISS. Let's see what we got here. Mark Van Hee and Thomas Pesquet. Yeah. Cool. Are unloading the capsule here in this picture. If you're wondering why they have masks on, they have to go into the Cygnus and they have to sweep. If the Cygnus has a leak, or if it has gases pooled in there that you wouldn't have detected on the ground, they go in wearing masks just to be sure, because like when you're down on the ground, if they sweep it right, and it just says you have total, you've just nitrogen right and oxygen right, there could be gas pooling at the bottom of the capsule or at the top of the capsule. When you get up into space, those gases just kind of float around. So they usually go in with masks and ventilation equipment just in case. You can see they have the vent line in there. See, that same type of positive pressure thing that I was telling you guys about with stages and stuff, they do that on the ISS as well. They take a tube and they put this in the very back of Cygnus and they put the edge of the tube there and it blows air into the Cygnus capsule and air comes through this back into the ISS so the ISS can circulate the air. Full sensor sweep, Mr. Data. Alright. So, yep, there you go. They're coming through this common berthing mechanism right there. That's the CBM. That's what a CBM hatch looks like on the inside. Pretty cool. And there's the capsule. So it looks like we got a couple of refrigerators right there. Those are space refrigerators. And then this is all supplies and stuff. Clothes, towels, food, all good stuff. Seat belts. It's got snacks. Yep. Pizza. Yep. Cool, cool. All right, next bit of news here. Space refrigerators, are they better than Earth refrigerators, right? Well, yeah, of course. It does the exact same thing, but if you put space in front of things, it sounds way cooler. So, like, space toilet. Spaceship. Space bed. Space pizza. Space X. Yeah, without it, it's just X. Space heater. See what I'm talking about? Space plane. I mean, it is cooler. I'm not going to sit here like it isn't. Alright, space NASCAR. I wish. Does it have a lot of space to it? Yes. Why do we call them spaceships? Because they're a ship that goes into space. Space snacks. Space cadet. Alright, next news. The United Arab Emirates has selected Lacus Somniorum, Lake of Dreams, as the primary lunar landing site of its Rashid rover. 3 other backup sites were selected. Site is the northeastern area of the moon's near side. Launch window is August through December of 2022. Cool. Neat. All right. Well, that's pretty cool. Cool. And then, okay, so there's this next thing here. Who linked this? What are they launching on? The last time they launched something out there, it was, what was it, guys? It was a Japanese rocket. I didn't know this payload was a thing. It's actually pretty cool. Okay. How did you even know? I haven't shown it yet. Alright, anyway. So, Phil, what is this? The Mars Outpost demo is an experiment with the overall goal to demonstrate metal cutting in space and explore the feasibility of reusing abandoned space vehicles. The experiment will be launched on the second stage of a Falcon 9 vehicle on a dedicated sun-synchronous rideshare mission. The experiment remains attached to the second stage throughout the mission and during deorbit. Stage 2 will be inserted into a circular orbit 545 at 97.5 degrees inclination. Transmission and experiment initiation will be enabled by the Stage 2 onboard computer after the deployment of satellite payloads from Stage 2. This is estimated to be about 45 minutes after second stage engine cutoff. After completion of the mission, Stage 2 will be deorbited. The payload system is a cutting experiment. A video camera will record a high-speed cutting wheel cutting a coupon of CRAS 316 stainless steel. Stainless steel. The experiment will demonstrate cutting characteristics in 0G and vacuum. It's this experiment from Nanoracks. Mars Outpost demo. Do you have the forward flap thread? Stop flapping your gillet at me. Of course I do. Now. Thanks, man. Nanoracks likes to show Centaur stages for their outpost stuff, so most likely related to that. Shut up. Shut up. Just... Have they ever welded in space? Not that I know of, but I don't know for sure. Alright, let's, that's pretty cool, Phil. Pretty cool mission. That's gonna launch later this year on the transporter. Couple more things here for this space news. Alright, I'll save the Starship stuff. I'll save the Starship stuff for last. So, let's go here. Dr. Williams. I just had this sent over WhatsApp to me. What is this? Is this a paper model? Oh. I want this, but I have no reason for it. I don't need this, but God, do I want it. Is it 3D printed? I can't tell. It looks kind of like a paper model. I still have the 3D printer. Dude, I mean, we'd have to model it. I'd have to model everything here. That would be a lot of 3D printing. A lot of filament. You need it to teach stream. It's a business expense. I like the way you think. I mean, the TSMUs they look like they're made out of paper. That's really freaking cool. Yeah, that's pretty cool. All right, next bit of news here is coming from Thomas Pesquet. What do we got here?
Ok, la semaine dernière, on a aussi reçu un nouveau module à bord de la station spatiale. C'est très rare, donc on est content d'avoir été à bord au moment où ce module est arrivé. Il a remplacé un ancien module russe qui est là depuis 20 ans. Il s'appelle MLM. On a eu quelques aventures à la suite de ce docking. Parce que malheureusement, quand on l'a intégré au système de la station, il s'est cru en plein vol, donc il a commencé à établir son orientation personnelle. Le seul souci, c'est qu'il a entraîné la station avec lui. Alors on a rapidement corrigé la situation, mais voilà, c'est l'espace. Parfois, ça marche pas comme on avait espéré, mais on a des procédures pour ça, on a l'entraînement et tout le monde était prêt. Je vais vous faire visiter ce module. On va vers l'arrière de la station.
You're covering the subtitles. What, you can't understand them? He said, I'm going to give a tour of the Nauka capsule, or the Nauka module that was attached to the Russian space station, or part of the Russian operational segment of the space station recently. Unfortunately, it thought it was still flying after it docked, and it caused a little bit of a, but that's space, it's not, everything is fine. Here, let's go look at it. So they're in PMA-1 here, moving into the Zarya module. Rasvet is down there. Okay, so we're going through Zayara. Those are poo containers right there. Just thought I'd let you know. You know a bit of French, yeah? A little bit, just a little bit. Okay, so now this is the airlock here, moving into the forward node on Zvezda, which is the Russian, the Russian service module.
Voilà, c'est ici que ça se passe, vers le bas, vers la Terre, le module le plus récent de la station spatiale, 2020.
Oh, cool.
On voit ici le sas qu'on a ouvert. Alors à l'ouverture du sas, quand on a un module qui vient de l'espace, ça sent toujours un peu le chaud, un peu le brûlé, un peu, moi je trouve, la crème solaire. C'est vraiment le cycle thermique, l'exposition à la chaleur du soleil qui fait cette odeur un peu spéciale et qu'on a retrouvé encore une fois. On voit ici le couloir central était plein d'équipements. En fait, nos collègues russes ont vraiment commencé à tout ranger, à tout déplacer, mais c'est pas encore tout à fait fini. Donc on va faire attention. On va descendre vers le bas de ce module. Ici sur la droite, on a des toilettes, nouvelles toilettes à bord de la station spatiale. Ce sera notre troisième toilette. Alors ça a l'air d'être un détail comme ça, mais c'est quelque chose auquel il faut penser quand on est dans l'espace et avec l'augmentation des équipages à bord de la station spatiale. Voilà, il a fallu trouver des solutions, ça en fait partie. On est passé de 3 à 6 à 7 et bientôt peut-être encore plus de membres d'équipage. Ici, beaucoup d'équipements qui seront des équipements scientifiques, des équipements de recherche un peu à droite et à gauche. On va aussi avoir une station de pilotage du bras robotique européen qui, lui, se trouve à l'extérieur d'MLM. Et cette station de pilotage, elle va se trouver ici. Elle n'est pas encore tout à fait complète. Mais vous voyez ici, ERA, c'est European Robotic Arm. C'est un bras robotique qui est l'équivalent plus simple de ce qui se trouve de l'autre côté, du bras qui se trouve de l'autre côté de la station et qui a été conçu en Europe et qui est arrivé à bord avec ce module. Vous voyez, on est en pleine installation, en plein bricolage. Ici, c'est une station de ce que les Russes appellent kayuta, donc une cabine en fait pour un membre d'équipage. Une structure rigide avec tout le confort moderne à l'intérieur et un petit hublot pour pouvoir regarder.
Space bed.
Pour l'instant, elle est occupée par du stockage. Et puis ici, tout en bas, c'est une deuxième partie du MLM. Et ça, c'est un module qui a une forme assez ronde, en fait, qui va servir à arrimer On voit d'ailleurs que ça résonne un petit peu, le son change, qui va servir à arrimer d'autres modules. On va avoir notamment un SAS ici qui va nous permettre de sortir des expériences vers l'extérieur d'MLM côté russe. Et on a une nouvelle fenêtre qui pour l'instant est fermée, mais qui peut s'ouvrir, vous voyez, un peu comme un objectif d'appareil photo, qui est assez vaste en fait, assez grande, et qui regarde un petit peu à 45 degrés vers la Terre. Donc ce sera vraiment un super endroit pour observer la Terre, une fois qu'on l'aura ouverte, mais malheureusement ce n'est pas encore au programme. Voilà, pour la première fois en exclusivité, la visite du module MLM. Merci de l'avoir suivi.
Merci Thomas. Cool. Cool. That's neat. Interior tour of Nauka. That's the new module that was up at the ISS. Pretty cool. Yeah, it was all in mono though, but that's okay. Okay, sweet. Let's see. Can you link that? Sure. All right. Let's go here. NASA LSP. I know guys that work in there. Landsat 9 is encapsulated. We can talk about that. Sure. So, Landsat 9 is a climate observation satellite that's going to be launched out of Vandenberg Air Force Base by ULA. This is it going through what's called encapsulation, where they put it inside of a fairing. This is an Atlas 400 series fairing. Once again, launching on an Atlas 5 out of Slick 3 at Vandenberg. Vandenberg. Thomas did a tour sooner than the Russians, really? Jeez. This is the most recent vidya. Alright. Cool. Here, how about we look at this? Physics is fun. Okay. Whoa, that would be a little sketch. Okay. Yeah, I don't... How do you get off that thing? Yeah, you almost got hit by a short bus. What's the bus driver supposed to do? Wait. The bus is on the wrong side of the road. It almost threw the guy into the front of a school bus. Huh. Okay. Yeah, he did hit it. He hit the mirror. Interesting. The reason why I linked that in the first place is because low center of mass. Bit like our ship and booster on re-entry. Have I seen this yet? Oh no, no. Oh, I don't want to watch that. I don't want to watch this. I know where this is going.
Is everything correct? Done you alright?
No! No! Stop it! Stop it! Stop!
Boom! Jeez! Boom!
I don't know. Speaking of Tesla's crashing, here, watch this video. This was the low center of mass thing. Bus driver must have... Dude, he went like this. He went, no! Winged it. That's pretty rad. Wow. Jeez. Look at how rigid the Tesla stays. That's unbelievable. How it can absorb all that force, but it doesn't deform is pretty damn impressive. And here's human music.
Discovery Houston, press to ATO.
Hey X, thanks for the host, man. Jeez. Yep. I mean, even that head-on test, dude, look. That's kind of crazy, man. I really wish we saw the end of that footage. It cuts to the next thing. That's super interesting. See, they have a deformation line right there to show how the chassis is moving. That's actually really cool. Whoa. The frame is like a wishbone on the Tesla. See that? It's like it's a wishbone, right? So when this teal bar gets hit, these two crossbars, the two frame rails, cave in on themselves. And then the red caves in on itself after that. Oh, that's freaking cool, man. Look at that. Yeah, the drive unit subframe. That's it's a double wishbone. You see that? It's like a turkey wishbone. Oh, that's freaking cool, man. I mean, look at the. So the reason why they did this is to protect the battery tray. You can see this is the forward cross member or the forward crossbar for the battery tray, right? Watch. Crunch. This teal bar basically it takes the pushing force that's being applied to it and converts it into lateral compression. That's really cool. Dude, that's smart, man. Yeah, you don't want the battery tray to get hurt, and that's where the people are too, so you don't want them to get hurt either. Look, see the red crossbar? So the teal bar, the more the teal bar bends, the more it pulls the purple in, the more it expands the red. They're taking a collision force and making it go sideways. That's really friggin' cool. And look, the bars, if you look at the red crossbar, it's intentionally kinked right there. See that? It's kinked right where the lower control arm attaches to it because it's designed to bend. See how they ridged it out here? On the ends, right there, it's got a flap on it. They ridged it to make it strong right there, and they intentionally made it weak right there. So when it crashes, it deforms right in that weak spot. That's really freaking cool, man. That's really smart. How do you even think of that? See, it bent right there. That's where it's supposed to. That's really cool. Yeah, this is looking underneath it. This camera's pointed up and the thing's crashing like that. That's really cool. That's really, really interesting. I designed Dart to do that, believe it or not. I designed Dart to shear in certain places. That's how Bob and Bill survived that crash. Unfortunately, Jeb didn't, but he was supposed to. It should have, but it was a freak accident with the landing gear. Oh, that's so cool. Look at it. That's really smart, man. That's wild. That's wild. Very cool. Oh. All right, anyway, so what else do we got over here? Another thread. Part 3 is live. By the way, there's a slight error with There's a slight error with the forward flap design. Moving section is needed for control, but passive section is counterproductive as it pushes the nose backwards. New design rotates the forward flaps more to leeward and further forward to improve the moment arm, maybe 120 degrees apart. Yeah, I see. Yeah, I got you. Well, Thomas, that explains why they changed the payload bay door design. Can't do a chopper fairing with this. You can't do a chopper fairing with that thing. No way. You can't have the fairing, you can't have the arms be on the fairing. No way. There's your payload bay change explanation. That's why they switched it. Yeah, that's the exact reason why they switched that. Cool. What is it now? Make it more pointy. Make it more pointy! We have to make it more pointy. Not space news. Had a bit of a scare with my brother today. Some of his stroke symptoms got worse. He seems to be okay. The doctor says it could be stress, illness, or dehydration that made it flare up. Oh, jeez. Well, I'll keep him in my thoughts again, Draco. It worked the first time. Might as well do it again. They switched it because you hit the enter key too early, Boxy. So we saw them cut out a nose cone. They had a nose cone and they cut out a payload bay that on the top that looked like the shuttle's payload bay. And they said it was a Pathfinder. And I said that they would do something like that, but it's cool to know that the reason why you know what? Let me load up my 3D model. It's easier. Here. There's more in the thread. Okay. Like this, and further forward towards the nose too, but I think that seems about right. Probably slightly further forward, smaller and more inward. No funny looking static arrow at the top, as static arrow is no longer directly in the flow. I'm surprised the static arrow on the bottom flaps isn't an issue too. Will they end up pushed back 120 degrees from each other? No, the bottom static arrow pushes the engine section back, counteracting Starship's low center of mass on re-entry caused by the engine section. Aiming for 60 to 70 degree angle of attack during high heating portion of flight. Don't want to re-enter with the engines being blasted by plasma. Okay. Here. So you have Starship, right? Here, let me just I'm gonna have to make some wings here real quick. Give me a moment. This won't be on the final exam, class. All right, so you have one wing over here, right? These are the back wings. Those might be a little bit on the large side. Just bear with me. They are. They absolutely are. They're way too big. All right, so just... All right, so you have that right there. You know what? Just delete it, and I'll duplicate it again. And just actually, a better way to do this would be to give me one moment. There. So you have those, and then you have these up here. The forward wings. So the forward wings are actually kind of like this, right? And they're obviously a lot smaller. Something kind of like this, almost, I guess. So what Elon's talking about is, you know, picture that Starship is re-entering, right? And the re-entry heat is coming at it this way. There's the wing being right here, right? So it folds, obviously, right? So it folds up out of the way, right? The wing, if its hinge point is out here, it's still in the way of aerodynamic forces. See that? Still in the way. Even the passive control surface is still in the way. Right? So what he's talking about doing is taking the wing. You know what? That wing just looks horrible. Let's just make it not look that bad. Kerbal sure changed a lot. Nice. There we go. That's a little more Starship-y. That is your vocab word for the day, chat. So, what Elon's talking about is taking the wings and moving them up here and putting their pivot point up here somewhere. The reason why is when your pivot point is up there, when the pivot point is up there, you're out of the way of the re-entry heat. See what I'm talking about? Not exactly like this, but close. If I take this and I move this over here, like that, and the wing is up there and it rotates out of the way, on the leeward side, it's out of the way. There's no holder marking it. There's no hinge cover mount right here to provide drag on the front. It gives it a more natural center of pressure. And then these back wings down here are counteracting the center of mass. Those ones are mounted just fine. They have like a passive aero cover. Then you don't need thermal protection system for the hinge. He was talking about that. He was talking about that, right? They made a lot of updates. Yeah, right? Starship-y. Yep. Mm-hmm. So the wings will fold right here, like that. They're high mounting the wings, right? So if they high mount the dang wings, right? Okay, so group. If they high mount the wings, give me one moment. If they high mount the wings like that and move them further forward, so here, let me group that. I see what they're trying to do. You're not going to need as much thermal protection system for the wings. They're basically going to high mount them. So now SpaceX wanted to do like a chomper fairing here. They wanted to have a fairing like that. See? I don't know who did... Okay, this is Neopork's render. See this? I've always said that that's not going to work. But I said it for the wrong reasons. I'll be honest with you. I said that wasn't going to work because the payload integration would be nigh impossible on the ground. It would be really, really difficult. Because if the thing only opens up like this, right? It only opens up like that. You have to move payload down. You have to move payload diagonally. That's hard to integrate payload that way. And it looks like they strayed away from it anyway. Because see this little thing right here. See this little lip? That's what Elon's talking about. You don't need that passive arrow right there. See that's passive aero because it's an aerodynamic surface that's covering up the hinge actuators on the wings, right? If you shift those wings up to the top, up and over, right? Like that, you won't have that problem. But if you shift them up like that, you can't make this fairing anymore. That fairing doesn't work. The chomper fairing won't work with the wings mounted up here. You can't do that. So stuff like this can't be done. So that's why I think they're switching to a different payload bay design, which is pretty cool. Yeah, so you can't do the chomper fairing because there's wings in the way. So you gotta rethink how your payload bay is gonna work. I'm still worried the new wing location is gonna make standard payload bay doors harder. Thoughts? If they move them forward, and because the header tank is already there, Blue? No, it's not. It won't make it any more difficult than it needs to be. So, like, if they're moving them all the way to the front, like all the way up front, like that, you still have plenty of payload bay, but you can't use the chopper. You can't use the chopper fairing. I mean, you might still be able to, but at that point, you know, because the payload bay basically starts right here. 1, 2, 3, 4, 5. It basically goes to about here, and then you have your header tank up there. Why? Because you put stuff up at the front. Why would you not use? Right? What if you make the payload bay on the bottom side? Well, you can't. There's tiles in the way, Gabber. The whole point was to minimize aerodynamics on the back side of the vehicle. So Starship might end up looking like this. That's weird looking. The flat placement determines the shape of the floor. Yeah, Entropy, I know. Yeah, I know because I said that like at the beginning of this spiel, but it's cool. Yeah, I know. I said I was right for the wrong reasons. Yeah, no, I know. Moving the flaps up is more likely the result of the payload bay design decision, not the integration stuff that I'm talking about. I said that already. You must have missed it. But yeah, interesting. So Starship might end up looking like this. I don't know. What do you think? That looks kind of weird, huh? It's kind of bizarre. Oh, you're still right for the correct reasons. Just reinforces that. I'm gonna say, man. I already said that. Why did you? What? Yeah, no. Yeah, the flaps definitely help. Like I said, I was right for the wrong reasons. I got the right answer, but I used the wrong formula. Story of my life, dude. Story of my freaking life, bro. Sorry, man. I was like, I just said that. You know? That's weird, man. That's gonna look bizarre. Anyway, bottom static aero forces and what impact will these bigger aero surfaces have on the cross range? They're actually smaller. If they move them forward, you don't need to make them as big. It's gonna look like that. Oh, that's strange. That's really strange. This change sounds like more of Elon thought of it last night because he isn't even sure what it should look like. Yeah, this doesn't look bad, Core, but it's definitely weird. I mean, at that point, why don't you just opt for passive aero down here? Like somebody said, oh, the BFR 2017 design. Well, I'm wondering why don't we just take this design, right, and combine it with combine it with the delta wing. Right? You want passive aero down low, but then again, you need that to flip. You need that to do the flip. Yeah. You need that to have it flip. You need those wings to fold up for it to do this. For it to do that. Right there.
Discovery, go at throttle up.
Interesting. Cool. All right. Would fascinate you to see camera views from the bay during re-entry. I'd like to pretend it's for some scientific reason, but I just think it might be awesome. Hell yeah. Anything else from Elon there? I think that was the last thing. Bottom static arrow pushes the engine back, countering the Starship's low center of mass on re-entry caused by the engine section. Okay. I canceled Apple News as a major source of negativity in my life. Same. Elon. Apple News, bro. Holy crap. That's a space machine gun, man. Will these changes mean more tests from Boca Chica? It's possible. Saturn news, if you care. Saturn's insides are sloshing around. A new paper suggests Saturn core is more like a fluid than a solid and makes up more of the planet's interior than we thought. Oh, that's cool. Neat. I'd have to read the paper. Yeah, see? Okay, take a look. Take a look at this picture. This is a picture of when they integrated it. See this? See that? See that little lip right there that holds the hinge? That's what he's talking about. That's the passive arrow. Passive arrow is something that doesn't move, as opposed to the active arrow, which is the wing, right? They're trying to get rid of that on the front because it'll create more aerodynamic stability during re-entry. They're basically trying to simplify the thermal protection system. Wait, did I miss the big launch? No. Big launch. No, he hasn't. They haven't launched it yet. No, it's not even close. In fact, I can give you an update. Here. Have an update. But look, NSF made you some content. They made you your favorite open wide. Here comes the content. It's a beautiful day to tank watch. All right. Oh, they finished painting the launch mount. That's cool. Man, look at how big that thing is, dude. Look at the guy standing next to it right there. Little teeny boy. Come here. Come here. Oh. Squish you. Sorry. It would be nice if they could use Batman cape style wings. That'd be kind of cool, Zeep, but unfortunately, like, here's the thing. When you're coming through re-entry, you need wings that can basically resist having a flamethrower shot at them. Actually, even hotter than a flamethrower. Yeah, it would be like trying to make a boat hull that can sail through, like, lava. Yeah, that's what you basically need to do. We're talking 1600 C during re-entry. probably more if you're coming back from Mars. And if I was SpaceX, I'd rate it for a trans-Earth injection coming back from Pluto, if it was me. That way if you're coming back from Mars, it'll work right. The thermal protection system is key. You can tell that SpaceX, that's really where SpaceX is focusing right now. I mean, on top of getting the pad ready, they're really focusing on Starship's TPS. Because once again, I'll say it once, I'll say it again. When you're building a reusable launch vehicle, and the only evidence that I have is other reusable launch vehicles that have been made in the past, right? Or any reusable vehicle at all. When you're working on a reusable vehicle or a capsule or whatever, you start at the end of the mission and you engineer your way back. Why? Because if it doesn't have parachutes, the capsule isn't landing. If the shuttle's wings don't work, the shuttle is not landing. So you start there. You start with the thing that you absolutely need. And then you work your way back. I've noticed this. They did this during the space shuttle. They did this during Apollo. They did this with Orion. They did this with Dragon 2. They did it with Starliner. What do you mean they did it with Starliner? Well, one of the first Dragon 2 missions we saw was the pad abort. Starliner, they all start with parachute testing and in-flight aborts and abort systems to make sure the capsule can land. That's the first thing they do. With the space shuttle, what was the first space shuttle missions? Approach and landing tests. They made sure it could land before they launched it into space. That's probably a good idea. Buran was the same way. Same stuff. Dream Chaser, they already did the landing tests. You start at the end of the mission and you work your way back, which is that seems kind of counterintuitive at first, but it makes sense. SpaceX already got the landing stuff figured out right there. So what's the next step? Re-entry. How are you gonna do re-entry testing without doing an STS-1? Well, build a minimum viable product super heavy, which is what we saw already. Stack it and send it, which is that's kind of nuts, man. But hey, it's still cool. So figure out what victory looks like, then figure out how to get to victory. Yeah, exactly. Start from the end and work your way back. Dread, nice. There's 20. See that little lip right there? That's what Elon's talking about in the tweets that he sent. It's a shame. I'm kind of getting used to this. My guess based off of what he said is that where the tiles terminate right here, that's probably where the new wing mount's going to go. If I had to guess. I mean, he did say 120 degrees, but it sounds like they're just going to shift the wing position up. It's a whale, no you. Yeah, Josh, of course. But you can't test... Great, you tested re-entry. If your landing system doesn't work, then what's the point? You gotta design backwards, which is weird. It's strange. Crane. Ogromny Chunguska. Man, look at the size of that dang thing. I kind of want to see the crane just like run over like a smart car or something. Just because. It'd be really awesome to just crunch. Did you see the Eric X renders? Not yet. So each one of these red triangle things right here, you can see they're bricks. They're stacked on top of each other. Each one of those is 10 tons, 10 metric tons or 10,000 kilograms, about 22,000 pounds, each one of them. 22,000 pounds. For example, a car, a bigger car, 1,600, 1,500 kilos, about 33,000, 3,500, 4,000 pounds, somewhere in there. Yeah. Each one of those is like 20 cars. Yeah, just for the record there. Yeah. Okay, heavy. Look, you can even see that the entire house is tilted. The entire house is tilted back this way a little bit. Or 6 small American cars, that's right. Buckner. Bird. SPMT. That guy's sitting on a bucket. Bucket! Chevy. Bird. Volkswagen. What's with all this trash around here? I keep smelling this trash, man. Actually, that car's kind of cool. That's lifted avalanche. Is it just me, fellas, or do SUVs with low pro tires just look silly? Low pro tires on trucks just look silly. That just looks silly. Bird, Dodge. It looks weird. All the bros have like that kind of stuff. I'm like, why? Why you put? What? I don't know. No, the Avalanche doesn't look silly. Avalanches are kind of cool. Tahoes are the Chevy SUV you want. Tahoes are the best, man. I love that truck. I want one. I want 3. God damn it, I have a problem. Like, I'm saying that as a Ford guy. I want a damn Tahoe. Hell yeah, that's a great truck. I drove, yeah, Pavement Princess, exactly. Yeah, we need an El Camino to pull up. Now we're talking. That's what we really need. Yeah, that's what I mean, dude. If I get a truck, I don't want some fancy rims. I'm gonna be worried about breaking those. Just give me a Steely. Give me a Steely with a big heavy-duty tire on it. That's all I need. I mean, shoot. Just need a TJ? Nice. Like, see that dually right there? Hey, yeah, see, that dually could rip that Avalanche in half. I like to see that. That's what I'm talking about. It doesn't need no fancy rims. And it's funny because there's a Brodozer right behind it. And don't get me wrong, I'm not hating on Brodozer. Like, if you want to do that, you want to do that. I just never understood it. I respect it, but I never understood it. Everyone wants a next-gen Elko. Yeah, I know. Yeah, Brodozer. See that Super Duty right there? See that looks nice. That looks right. That looks like you can do work with it. The Brodozer's got a real toy truck thing going on. Old Bird. One of these? Hell yeah. Geeson, that thing looks super freaking useful, right? Like, oh yeah, no, this is EJ's style right here. I want a truck that does things. Because if I'm gonna buy a big, obnoxious, big vehicle like this, I want it to be useful. That thing is sick, dude. I mean, you could rip stuff in half with it. You pull stumps out with that thing. That's a truck, man. Look at that. How many lugs you want on the rim? Yes. How many lugs you want? All of them. Give me your lug nuts. All right, let's keep going. Ugh, the RB stop. Ugh, God, no. You live in an apartment. I know. Don't remind me. Yeah, see, look at that. See? That's what you use that truck for, Geeson. There it is. It's got the gooseneck on it. It's so crazy. It's so crazy, dude. I love it. It's so, dude. That tower is gonna look like a gigantic Gundam that catches boosters out of the sky. You prefer the Hilux? I can respect that. But that dually will rip a Hilux in half. You understand this, right? Look at that thing. Is it taking off today? Nah, Taylor, we're not even close, bud. Yeah, but the Hilux is still run. Yeah, but it'll be ripped in half. You'll just have two wheels going around like this. You can't compare heavy duty to light duty trucks. That's what Cybertruck did, man. Nice looking rocket though. Oh, I do like the rocket. The rocket is very, very pretty. Yeah, see? So, alright, a little bit of an update. You're looking at 20. 20 has a lot of broken tiles on it. They took a lot of tiles off. They have a lot of busted up stuff in here. See that? See, look at all the tiles that fell off. So, you know, everybody couldn't figure out why they would go and stack this thing. Why would you stack it? That doesn't make any sense. I'm pretty dang sure that they were stacking this rocket because they wanted to see if the tiles popped off when they stretched. Because when you pick Starship up, it's going to stretch it. Starship is under compression load. If you put the tiles on under compression load, right, because the weight of the vehicle is pushing itself down against the ground, right? The tiles, you attach the tiles when it's compressed. When you pick it up with the crane, the entirety of Starship is going to stretch out a little bit, right? It's like if you hang from a monkey bar, you're a little bit taller that way. Or how you get a little bit taller when you're in space because your joints all stretch out, right? Same thing. The tiles popped off. Yeah, that's, interestingly enough, a problem that they had with the Space Shuttle. Space Shuttle did the same thing. The early versions of the tiles popped off when it was on the ground still, just like this. Would it also stretch when it got in the warm sun? Thermodynamics exists for a reason, Hip. Yes, absolutely. They're trying to solve those problems. That's why, I'm pretty sure that's why they stacked it, dude. They stacked it to see how much the tiles would pop off. Look at all of them. Look at all the tiles that popped. So do we know when Starliner's launching? Nah. How do you fix that? Well, the way they fixed it was glue that could stretch with... The glue would stretch. They glued the Space Shuttle tiles to the Space Shuttle. And the glue they could heat the glue up and it would stretch, but it would keep the tile on. That's what they did. It was a process called densification. They did that, and yeah, they ended up gluing the tiles on, because if you have two bolts that bolt the tile to the... If you have two bolts that bolt the tile to the spaceship, right, and it bends, and the spaceship bends, or it stretches in this case, right, it's going to pop the tile off or crack the tile, and that's exactly what happened. SpaceX has gone with a mechanical fastening system, and look at how many tiles it popped off. Don't get me wrong, that's not to say that the tiles are a bad idea. It's not a bad idea. It's a good idea. That's the best way to do it, seriously. That's what the Space Shuttle did that, and once again, I know people are going to be, oh, but EJ, the tiles. Well, first of all, the tiles weren't the problem. It was the RCC, if you really want to be, technical there. The shuttle lost tiles, and it could come back, no problem. Well, not really no problem, but it could. STS-27 is a good example of losing tiles and it coming home. But the tiles are the right way to do it. There's really no other good way to do it except for something that straight up passively resists the heat. But the problem is there's not a lot of stuff out there that'll just straight up resist 1600 degrees Celsius. That's not a thing. I don't think we have a material that can do that for long periods of time. Yeah, they did. With that being said, SpaceX did glue some tiles. They glued some tiles to the wing leading edge right there. See where the tape is? They did glue some stuff. What about multiple bolts in the tiles? They have 3, actually, Nighthound. So that when the hull stretches, the distance between the bolts doesn't. Wouldn't that stop the tiles from cracking? Clearly no. No, clearly it didn't. That was SpaceX's idea, for what it's worth. See, 1, 2, and 3. It clearly didn't stop. It clearly didn't fix that. Not a lot of the tiles cracked, but some of them did. Which could be, that might... Like, a lot of them didn't crack, but some of them did. The ones that have tape on them are the ones that they indicated cracked or popped off or something. I'm not really sure what the exact indicator of it was, but... And once again, this isn't a knock on the tile design or a knock on SpaceX either. The tiles are the right way to do it. I mean, they're real, dude. The tiles are basically cheating. You're not gonna find something that's as light, operative word, as this that resists the heat. Like, even if you made the Starship out of, like, a giant piece of steel, and that steel could go right through re-entry, you wouldn't have to do anything. Even dealing with the complexity of this is still a magnitude lighter than, like, just building a, like, basically a battleship that comes down through re-entry, right? The cool thing is that, and I saw this from Scott's video, I thought this was Nomex, the white cloth that's behind him, but it also could be aluminum cilia, which would mean that SpaceX is taking a page out of the X-33's book. X-33 had aluminum cilia backing a metallic tile, which is actually pretty cool. I think metallic tiles might be a good way to do it, because even though they're heavier, right? I mean, these are tough and unifibrous reinforced oxidation resistant carbon. Tough rock is what it's called. Those tiles are good, but you know, even if you carry a heavier metal tile, the ship's going to have more mass, and that does screw with your payload capacity, but the thermal protection system never falls off. Hey, Dizor, 30-month resub. And it's way more expensive. The X-33's thermal protection system would have been insanely expensive. Yeah. Yeah, nickel titanium alloy plated tiles backed with aluminum cilia fibers in an Inconel box, and 4 bolts. Yeah, that would have been a little expensive, but you'd only need to buy it once. Would there be any way to create an active cooling system? That's called transpiration cooling, Riv. Yeah, that's absolutely a thing. Yes, you could do that, but you're increasing vehicle complexity. Now you need to carry around the extra things that you need to act as a gaseous intermediary between the plasma and your ship. The tiles just basically absorb the heat and push the plasma out of the way. Is it possible to make an aerogel thermal protection system? I don't know. Maybe. And yeah, that thing's got some chunk to it, huh? What tiles are being used with Dream Chaser? I think it's using Tough Rock as well, Luizo, but don't quote me on that one. Also high risk. If it gets clogged, you're toast. Quite literally, yes. Burnt toast. Supersonic return propulsion. Yeah, you're coming in too fast to do something like that, Hulk. That face one, that pipe that's being lifted right there, it weighs as much as a car. No, they notched the pipe. It's like building a frickin' roll cage. Only a roll cage that you could literally crawl inside of. SpaceX Catch Your Arms or Adult Playground? I'll let you decide. Clown cannon. I made a crane in KSP, but after lifting a few modules, it had always folded in on itself. Is there any way to reduce this? Make sure your docking is lined up, Jack, and make sure everything docks to the crane, not vice versa. Set the crane as a base. It should help, but you really got to take your time with lifting things. Man, look at the catcher arms. Holy crap. Nuts. Nutso. That's the QD. Quick disconnect. This arm will help supply propellants to Starship before launching on. Yep. Some kind of dowel pin on a bearing right there. I'm not sure why. I'm not sure what they would be using the dowel pin for. Maybe just to keep that channel clean. Who knows? Because so where this rod is, that it looks like an aluminum rod, but it could be steel. I don't know. Where this thing is, those are bearings right there. See these kind of sleeves right here? And right there, that's a bearing. And then they clearly have something holding it. There's a huge bracket and a gusset right here that's holding that thing in place. And then this is where the arm will pivot up against the tower. I'm not sure why they'd be putting this pilot dowel in here. Maybe that's the reason. Maybe it's a pilot dowel. So, like, when they go to lift the thing up and they, you know, try to get it to line up, they have that pin there to line it up, and then they could put the real hinge in there. I don't know. Either way, that's solid. That's solid, whatever it is. That's not a pipe. This thing is solid, which is nuts. That thing's probably really freaking heavy. I'm pretty sure, Thomas or anybody else, is this leftover parts from the space frame from the oil rig? I always wonder why these were painted yellow. I think these are leftover parts from the oil rig, dudes. I think they just scrapped the oil derrick and made this instead. Thomas, do you know? It looks like why is this part yellow and why is that black? Hang on. Let's see if we can look at a picture. Any yellow space frames on this thing? I can't tell. Maybe. All of it used to be yellow. Dudes, did they? Here, hang on, let's see. I know they lifted some parts off of the oil rig for the catching mechanism. I know that they did that. It's possible. I don't know, maybe. There is a lot of yellow here. Why else would it be painted yellow, you know? Maybe they scrapped the oil rig because we know they're disassembling it. Maybe they scrapped the oil rig and took some parts. Like the space frame from over here. Hang on, let's see. Oh, I spelled it wrong. Yeah, so I'm seeing a lot of yellow in here. Tatoidi, 58-month resub. It's possible, like, maybe they did. I don't know. I mean, I'm going to say probably no, but look, oil rigs do have really nice space frames. See that? Maybe it's not from Phobos and Deimos. Maybe it's from something else, because that looks like the right parts. Yeah, maybe it's scrap. Maybe they were scrapping an oil rig from Brownsville and SpaceX went over to be like, hey, can we take those pipes? I'm trying to see. Is there any yellow space frames on this thing? Nope. There's the lifeboats. Cranes. Maybe not from Phobos. Yeah, okay. Yeah, I don't know. Dudes, Thomas, go digging. Can we... I mean, it looks like... Those look like parts from the oil rig. Why would they be painted yellow? Or it's parts from something. Like, I don't know. It's just something I was thinking about the other day. You think... I mean, SpaceX would be the kind of company that would just be like, hey, we could use that. Take that thing apart. Use it to build a launch pad. Go. Yeah, SpaceX does stuff like that all the time. They do, yeah, exactly. Dumpster diving, Reisty, right? Yeah, that's what they do. They take parts off of other things and put it on other things. Like, maybe it's possible. Also, hey, want to see something cool? Look, fuel lines. Right there. Fuel line. Actually, that would be your oxidizer line. The methane line is the smaller one. But see, they're right there. There's your fuel lines. These two, right here. We stopped making oil rigs here. Now we have convert tankers to do the job. Oh, all right. There's the lines right there. Well, yeah, Tessa, I mean, that makes sense. That's SpaceX in dude, in a nutshell, there's a service gantry right there. Marine grade steel is tough stuff, for sure. That's what I mean, dude. Like, why would some of this stuff be oxidized steel and the other stuff be painted metal? And it's just painted the exact same color that some of the equipment is painted on the oil rigs? That's too much of a coincidence, dude. We saw that there's some yellow, like this yellow, and don't get me wrong, they colorize stuff on the oil rig for user experience, so to speak. So I wouldn't be surprised if these are parts from Deimos or Phobos. Just scrap the parts, just take it. Yeah, sure, why not? We're gonna send these back to the mill. No. Give me those. Give me. We need that. What's that, Linprod? It could be. I mean, it's possible. I don't know what parts. I don't see any parts that kind of correlate to it on there, but it's possible. Yeah, Tessa, exactly. Or any number of oil rigs getting scrapped. These things have definitely been used before. It's from something. These are from something. They wouldn't deliver it like kind of from the factory if it was painted like that. That doesn't make any sense. The reason why you don't want to do that is because when you're dealing with that thick of steel, you actually don't paint it. You don't paint it and let it oxidize, and it forms an oxidized layer around the edge or around the surface of the steel thing that you're sending, and it actually protects it. The rust actually protects the rest of the steel. If anything, sanding it will make it worse. So if it was coming fresh from the factory, so to speak, right, it wouldn't be painted. I know that for a fact, and you can look at it next to the other stuff right there. The other stuff ain't painted. You can even see the oxidization going on right there. See how it's red? They let it rust because the rusting forms a protective layer. The QD arm before they painted it. Bro, that's leftover oil rig parts. Passivation. There you go, Demon. That's the word. Sorry, I couldn't think of it. Yeah. Freaking all, it's all, like, this has to be oil rig parts, dude. Well, maybe not oil rig parts, but SpaceX did just buy some oil rigs, you know? It's too much of a coincidence. It's got patina, bro. Yeah. Man, this thing came together real quick, didn't it? Yeah, Thomas said Deimos is in Brownsville, Phobos is in Pascagoula, Mississippi. Hey, this has air and gas in it right here. You can tell it has air and gas in it because of the way it is. Now, Airgas is a company that supplies different types of gases for pneumatic systems. It's a joke. Shut up. Me, that's a protective layer. Lunprod, you see anything resembling those parts on there? I don't see much. But there are stuff that's painted the same color, you know? They must have got it wholesale. That's SpaceX. That's what they do. Sounds better than air fart. Yeah, that's true. That's true. Cryo shell here looking real good. Yeah, hard pass on that. Yeah, hard pass on that guy's job up there. Props to you. That's the okay. Yep. Yeah, probably core. Yeah. Crews work on the high bay to prep Booster 4 for testing. What is that? What is this thing? What? Talk about some eye candy there. Pipes. Laughing pipes. They say you can hear singing pipes. Some people call them demons. I call them fools. Watch how Uncle Barbin works. Call the phone number and ask. No. That's not no. This thing is different. What do you think those are? A hydraulic reservoir, maybe? Or, I mean, it loops through whatever this is a couple of times. It could be some kind of exchanger. I honestly have no idea. I really don't know. It's maybe hydraulic oriented. I don't know. It's the beer tap. Yep. Equivalent of a charge cooler to cool the hydraulics. Yeah, maybe. Yeah, Vanguard, right. What the heck is this? Nope, you boy, I have no clue. I don't know. It's for the hydraulics. I mean, those look like hydraulic pumps right there. Never mind that. Look at the wire harness over here. Oh man, I did the wire harness on my truck and I thought that was difficult. What the heck is that? What is that? Look at that. The wire harness for that thing must suck so hard, man. That must be so difficult to freaking put together. Oh my goodness. That's oil cooling for the turbo pumps. Oil cooling? I would guess thrust vector control, Tessa, if anything. The turbo pumps use a hydrostatic bearing that uses the propellants. Yeah. Hydrostatic bearing using propellants. Mm-hmm. Yep. Could be an oil cooler. But once again, that would be for the thrust vector controllers. It's not for the turbine bearings. Tessa, the Raptor's turbopump design is based off of the integrated powerhead demo, which was an Air Force NASA project from the early 2000s. Yeah, they figured out a way to I mean, that's the reason why Raptor is ridiculous and why it can spin so ridiculously fast. Those turbopumps have like a 40,000 RPM limit. It makes a Formula One engine look like molasses, right? Those things can spin so ridiculously fast because they're using hydrostatic, which means they're using liquid as a bearing to get it to spin fast. They use the propellants as the bearing, which is just nuts. That's something my brain does not even understand. Like, I know what it's doing. I know what it's doing. I understand what a hydrostatic bearing does. But the tolerances there must be unreal. Will that even work with methane? IPH was methane. Yeah. Crazy, right? A hydrostatic bear, like Raptor's turbopumps can hit 40,000 RPM.
Go and throttle up.
Like, that was the constricting problem, believe it or not. That's why we couldn't just make a better rocket engine. That's why Raptor kind of seemingly came out of nowhere, and it can just do everything that a shuttle engine can do and make a shuttle engine look overly complicated and stupid. Because of the turbopumps. Those turbopumps can spin like at light speed. They can spin at plaid speed, which is unreal. Yeah, Solar, I don't know for sure if it's 40,000 RPM, but it's somewhere up there. That's how Raptor can withstand that super high chamber pressure all the time. Raptor's chamber pressures are like, what did Elon say? It's like 300 bar or something? That's unheard of. And to get to that speed up in an instant, I know, it's a marvel of modern engineering, AJ. It gives me goosebumps just talking about it. It's so damn cool. What was that? It sounded like fireworks. I didn't hear nothing. Yeah, and Raptor, yeah, and they're working on a Block 2 version already, Phil. Man, somebody pissed off Elon Musk that's clearly on Mars, and Elon Musk needs to get there so he can cage fight them. 330 bar! Morton, sorry, just tuned in. What rotates at that RPM? Raptor's turbopumps. They use a hydrostatic bearing design. So, Morton, I can say these words, and I understand and acknowledge what these words mean, and my mind's still like, potatoes. So, all right. It's a hydrostatic turbopump that uses the propellants, meaning that they are using the incoming propellants from the turbine as a bearing. Similar to how oil can be used as a bearing on your main bearings on your car engine. Hydrostatic bearing means you're using fluid as your bearing so the turbo pump shaft can spin. The hydrostatic bearings basically allow the turbo pump to spin at insanely high RPM, like 40,000 RPM. I don't know what it is off the top of my head. It's something way up there. It is way higher than any other rocket engine. I'll tell you that right now. And that's why Raptor can spin. They can spin the turbopump so fast that they can achieve that high chamber pressure. That's why Raptors are basically cheating. Yeah, basically cheating. Yeah, they use the rocket fuel. They use the rocket's fuel as the bearing, which is just... Alright. Alright. All Airbus engines have hydrostatic bearings. Yeah, but hydrostatic bearings aren't anything new, Da Vinci. Oil rigs use hydrostatic bearings. The gimbal on an oil derrick? Like, if you have a floating oil rig, how are you going to keep it from doing this in the water? And you have to stay over the well. So oil rigs have gimbals on them that are the size of a pickup truck. And those gimbals have hydrostatic bearings in them, so the derrick can stay like this, and the oil rig can do this underneath it. Yeah, it's pretty nuts, dude. Hydrostatic bearings aren't anything new, but the fact that somebody tried to put them in a rocket turbopump and use them to spin a turbopump fast that's the thing. That's what makes SpaceX, that's what makes those Raptor engines so damn good. Small block Chevy uses hydrostatic bearings. I mean, most cars use hydrostatic bearings because they use oil as a lubricant. You have to make sure that the tolerance is right. Man, that's mind-boggling. Mind-boggling, Synerd. It's 40,000 RPMs. What does that even look like? What does that sound like? Like, what does it sound like? Ah, yes, the dingle bop. Sounds like good. Like a dentist visit, quite literally, right? Yeah, that noise. That hissing noise. You're right. Sounds like that. Like a Dremel. Yeah. Unbelievable. That's a circular saw. Okay. Oh. 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 I love how the guy comes out from behind the trucks and he's like, That's a really nice circular saw too. That's a metal. That one's designed for cutting metal. That's a metal circular saw. Yeah, about. Oh no, the pallet broke. Pallet broke, guys. Look. That pallet broke. Yep. Okay, that's what happened there. Oops. It would have been nice to use, yeah. I don't know what this is. It could be a jungle gym, for all I know. I think he was trying to throw it off. Yeah, maybe. Maybe it's broken. Oh. Bum 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 dun dun dun. Bum 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 bum. Spum bum bum bum. Spum bum bum bum. Spum bum bum bum. Spum bum bum bum. Get the frick up. Spum bum bum bum. All right. Whenever you hum that tune, that means it's time to end Space News. Good news! Space News just got extended by another 30 minutes for that comment. Bum 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 bum. Bum 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 bum. Dun 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 dun. Get the frick up! Bum 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 bum. So that's the remains of Booster 3 over there. Joke's on you, I wanted Space News extended. Good news, everyone! Yeah. Yeah, it looks like they had nasty amounts of cracking going on in the nose cone. So, you know how you solve this problem? Don't pick it up from here. Pick it up from down there, which is what we know SpaceX is trying to do. They're trying to pick it up from over here. But they still did have a lot of stretching and deformation right here on the payload bay, in the barrel segment. Professor voice, the professor will help. Yeah, see, everything that's marked with tape right there, guys, is a cracked tile from what I can understand.
Discovery, go at throttle.
Green was surface defect, red was cracked. Thank you. Blue Flare, 18-month resub. Okay. I don't know. Picking it up by the armpits will be off center after they move the forward flaps back. Yeah, that's right. Yeah, that's right, Louiso. It's almost like the shuttle design is Genesis, man. That it's a really good design. So they put it on to pad B, huh? Okay. Question, and it might be a stupid one, but are those tiles supposed to withstand a very high temperature, and yet they can't take a little movement by crane? That's worrying, isn't it? It is to someone uneducated like me.
Listen, Tranquility Base here. The Eagle has landed.
Double chocolate chip. Da 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 da. Bum 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 boom. All right, can we ban someone for that? Soup doggy dog. All right. Uncapping, yeah. You don't want the tiles to crack. Yes, they are super fragile. Just because they can withstand a lot of heat doesn't mean that it's also solid, right? That was the Achilles heel of the space shuttle as well. Thermal protection system, it can withstand crazy amounts of heat. It's a material science wonder for the most part, but it's very delicate. That is one of the problems that SpaceX has to solve, dude. They have to figure that out. That's a problem that they had with the space shuttle. And if you look at the space shuttle footage over here, you can see the wing. They had to replace tiles on it every time it flew because some of them do crack. If SpaceX wants to make Starship work like an airplane, these tiles have to just straight up resist and not fall off at any point. They have to be strong. But SpaceX is cranking, they're mass producing the tiles. So because they're mass producing it and they keep mass producing them, they'll find a better design over time. What that design is, dude, I don't know. But yeah, I mean, for the amount of mass that you're attaching to the vehicle with all those tiles, for them to basically withstand the heat, it's worth it. There's really nothing better. I was talking about this just a second ago on stream. There's really nothing better. Like, tiles are so ridiculously light. Those Tough Rock tiles have the consistency of styrofoam. And you could literally hit it with a flamethrower or like a plumber's torch and it won't burn. It'll just absorb heat. It's pretty crazy, dude. What's the material? SpaceX's tiles are a toughened unifibrous reinforced oxidation resistant carbon. Tough Rock is what it's called. It's like Tough Rock is stemmed from a NASA project, and it was basically a project to make a better shuttle tile. Yeah, the shuttle tiles are silica based. They're basically rocks. They're basically a porous rock, like sandstone almost, but it has the consistency of like styrofoam. Yeah, it's about, and once again, it's about as delicate as styrofoam too. Well, maybe a little more, maybe packing foam. Why is the craft I downloaded from Kerbal X not showing up in the game? Put it in the right folder. You have to put it in your Save Ships SPH folder. Hey, Predominant, what's going on? When I was a kid, they would do demonstrations at the Space Center where they would blowtorch one side of the tile and then have you put your hand close to the other side. You could feel no heat. Yep. You did that. No, you didn't, because it didn't find it. You're missing a step somewhere, Reagan. You're a cyborg. Oh, that's good. Okay, cool. Da-da-da-da-da. Dang it, now I have that song stuck in my head. Ah. No, you didn't. No, I didn't what? Sebastian, what's going on? Nanoceramics in the future? You can't just combine two words together and say that that's going to happen in the future. Fusion thermal protection system. In the future, maybe. So it's on the test stand, huh? It's crazy, dude. Crazy. Hypersonic PUBG frying pan protection, yes. I mean, an Epstein drive might be able to do supersonic retro propulsion. With an Epstein drive, you don't even need to worry about re-entry heating at all. You could just slow down. Just burn all the way down. You don't even need to worry about it. No plasma will accumulate. The ERCX render of the new flaps. Let me see. New Starship flap design as described by Elon Musk. Yeah, Vasi, I think they're going to be up here. Is that cool or not? I can't tell. That's where I've recognized this from. That's where I recognize that from. Hold on 1 second. I can find it. Give me a moment. The Rockwell X33 has high centered. They have high canards like that on purpose. It's very similar. That's where I recognize that from, that shape. I just got to find a good picture of it. It was the Convair B9U. Convair B9U? B9U. Oh yeah. Oh, yeah. Well, yeah, there it is. Well, there it is. But see, they have underside deltas and then forward. And I think those are canards that... Wow, that's actually really cool. That person did a good job. Yeah, interesting. Huh. Is that an SSTO? This would have been a 2-stage. Those are... I don't know what was on the back. I forget, man. Yep. It was one of the original shuttle concepts. Yeah, that's right. Yeah. How much gimbal you need, man? All of it. Yeah, there was that one, and then there was Saturn Shuttle, and then that's what we have right there. That's what we ended up with. That's not a bad... honestly, that's not a bad way to do it. Jebstar 6. Yeah, that's where I got the idea. Like I said, I knew I recognized that design somewhere. I mean, it's just a coincidence. The what that thing does and what this thing does is two different things. Two way different things. Would rather have had liquid boosters over solids, but hey, you get what you're given. What's wrong with solids? Solids have moved more people into space than any other rocket engine. Fact. Stay mad. Stay mad. It looks weird. I don't mind it. I said that Rocket Guy was telling me, and this is why I said it, because Rocket Guy was telling me, he's an aerospace engineer. He's telling me that, having it be a circular shape, here, hold on. So, Starship is circular, right, on the bottom, and then having the wings, like that. Having the wings like this, that armpit right there is going to create a lot of heat. Rocket Guy actually told me that a long time ago, and he told me the better way to do it would be to take the bottom of Starship's hull and do this. But I think SpaceX don't give no fricks, and they just said put it up here. Put the dang thing up there instead. You'd need something that would end up looking like the space shuttle almost. Checked what arrived in the mail today from eBay. Oh, very nice negatives. eBay. eBay. Wow. Anybody know what that is? Yeah, General, most likely. It's a rocket. Yep. What kind? Spoiler alert. It's on the side. What is that, a Delta 5000? It looks like a Delta 5000 series. It could be a 5 or a 6000. Or it could be a Thor, but it's a Delta. It's a Delta rocket. It's an American rocket. Yeah, you're not wrong. So, I'm pretty sure that's a Delta 5000. Let's see what we got. It certainly looks the part. Delta 5000 was launched just once from Vandenberg in 1989. Huh. From Slick 2. Maybe a Delta 4000. Interesting. I found this while searching for oil rig parts. Oh, jeez, that's weird. Delta 1 through 4 and Delta 5000? No. No. Delta 6000s are Delta 2s. Delta 7000s are Delta... Or no. No, that's not right. I'll show you. I'll show you. Here. So, Delta 2 is 7,000. Delta 3 is 8,000. Delta 4 is 9,000. It's just the series of rocket. That's the internal code of it. There's Delta 1000s, 2, 3, 4, 5, 6, 7, 8, 9. Delta 4 is Delta 9000. That's just, yeah, it's just their internal naming convention. Delta 3 is so awesome. Yeah, but it's nothing, you know, compared to the Chad tier Delta 4. Delta 4 is a hell of a rocket, man. It's a shame it's on its way out. I'll say this till I'm blue in the face, man. These rockets, this guy over here, Delta 4 Heavy, is an extremely capable vehicle. Yeah, that RS-68, man. It's a shame that thing is, that production line's basically gonna die. Shame that. They should have just kept the Delta 2 in service. It just works. Falcon 9 put it out of business. Signer and Delta 4. A nice picture of the smaller SpaceX fleet. Ah, very cool. Who took this one? Rusty's Seafood and Oyster Bar. Hey, alright, cool. R68's on SLS-1. They tried that. Didn't work. We saved $30 billion. But EJ, the heat would have been too much. Yeah, okay. Sure. The ablative nozzle would have had to go. Okay, so we redo it and we make it a regeneratively cooled nozzle. Whatever. It's not going to take that long. Probably would have taken NASA a long time, but it's okay. At the time Constellation started, they would have had 10 years to figure it out. Yeah. That would have been just fine. Meanwhile, they could have tested their 5-segment boosters in J2 upper stages on King Ares 1. Yeah, but we got to... Guys, we can commercial can do it for cheaper. All right, I'm done. 30 more minutes. It was only 18. Shoot. I still have another 12 minutes of space news. It was a Delta 83. There you go. Which was Thor Delta M6. Thank you. Would have rather had that air-started RS-25 over the J2X. Why? I haven't talked about it specifically during Space News, Guinea, but yeah. Because it's cool. I'll take the J2X. Thank you very much. Yeah, I'll take that. Raptor is good, though, too. Yeah. Anyway, we could just sit here and stare at the wall for a little while. Did we ever talk about Sunday's race on stream? No. Vacuum RS-25 nozzle would be massive. Right. Can you tell which Saturn V is in the negatives? No. We could launch our SSTO. That's ready. Well, no. Space News is going to go for another 10 minutes now. We can stare at shuttle pictures. What about a raptor firing? No, that's pretty cool. Space News ends now? No, it doesn't. Here. You'd think that the curbs would be stronger. Yeah. It's pretty funny, actually. Wait for it. Wait for it. Wait for it. It's gonna take a second. What am I gonna eat? I don't know. Here's more news. What does this say? Oh, yeah, okay. Yeah, that's dope. Sequenced ignition right there. Bring the thunder. This should probably be cool for about a second, and then it wouldn't be right after that. What happened if you light 3 of those at once? Don't know. They sequence the ignition to mitigate structural load and vibrations on the vehicle during engine start. Engine start is a very violent event. Look. I mean, look at the nozzle on the top engine. And then the 2 bottom ones. What are those sparks for? Hydrogen purge, Warhawk. Yeah, you know how Delta 4, when it launches, it has that fireball that goes up the side? Yeah, you don't want that. You don't want that when you know, go to launch your space shuttle. Yeah, that's not a good thing. So they have a crazy amount of sparkers. They're radial outward firing igniters, or just, I mean, on Delta 4 they're called ROFIs, but on the shuttle they just call them sparkers. Another cool thing to notice is that these shuttle engines are creating such a negative pressure right here. They're creating such a vacuum, it's pulling the RCS plugs off of the Stinger. See that right there? See the plugs? These are just little, basically a sheet of paper that goes over the, it's not paper, it's Teflon most likely, that goes over the thrusters right there. And the engines are creating such a vacuum that it pulls them out, which is pretty nuts. You can see them billowing in the wind up there. Is that by design? Sure. They're designed to pop out with a vacuum. This vacuum just happened a little bit sooner. They put those on there to make sure that no birds or anything or dust or whatever gets inside of the thrusters. TSMU separation, SRB ignition confirmed. You see the excess propellant shooting out of the tail service mast. It'll go right down into the engines and get ignited by the exhaust. Man, that boiled off real quick. Did they stage the SRB ignitions? No. How are you going to stage an SRB ignition? What, are you going to light one and the other? Nah, that's not going to end well. Yeah, they couldn't. You can't with this design.
Discovery, go at throttle up.
It's a little. You know what? I'm getting vibes that it might be a little bit warm. Not here or here so much, But right in this area here, it seems to be a little warm. Yeah. Flat. 24-month resub. That's 2 years. Thank you. Yeah. Yeah, it's a little warm right in this area right here. It would cook a hot dog. Yes, that is, yeah. Yep. Yep. That's the SRB frangible nut and explosive bolt assembly. Watch. Frangible nut popped off the bottom and the explosive bolt cracked in half. The top of it goes up with the shuttle and the bottom of it falls down into a little channel down there, because you want your explosive bolt and frangible nut to be in a contained box so the explosion doesn't hit the nozzle. Also, something I've never noticed, when the SRB separates, it does this a little bit. It slews off the pad just a little bit. Watch. I've never noticed that. It goes this way first, and then it goes that way again, and then it goes back to straight. And then you can see the other SRB over there too. Wow. What the frick, man? How that doesn't melt, even being next to the flames, is beyond me. Like the little wire. Those are the wire leads for the frangible nut. This poor camera. Camera isn't facing in. The camera's looking through. It's bouncing off two mirrors. So the camera's down here. It's actually underneath the floor right here. And it's looking off of a mirror that's looking off of another mirror that's looking at this. Yeah, if the camera was right here, it would melt. It would melt. The shuttle doesn't exist because it's magic. Yeah, maybe. Yeah, sound suppressor here. Watch. So, see that bolt right there? That bolt goes all the way down into the pad. Okay? And then there's a thread on the end of the bolt, and there's a nut on the end of the thread. That nut's about the size of a grapefruit. And the nut it's put together like this, and it has gunpowder, basically. It's like two C's that come together, and there's gunpowder in here and here. When that charge goes off, the bolt breaks in half right here, and the nut falls off, and then goes right up into space. Yeah, I got you, Penta. I knew someone was going to ask. That's why I did it. Those are the separator motors for when the SRBs separate from the external tank. They pop off and go to the sides. The shuttle was immensely complex and high risk. Someone, I think that quite possibly is the most astute thing I've ever heard you say. That's right. Immensely complicated and high risk. But it also built the biggest space station ever devised by man. There's that. A new Chinese helicopter. Yep, okay. And it could have done more, that's right. New Chinese helicopter. Alright, let's see. Oh, look, someone posted it on TikTok. Oh, that's cute. Guys, why the hell is it being moved around on a lowboy? Why is it being moved around on a frigging lowboy? Yo, this thing's fake. That's a mock-up, dude. Are you kidding me? Budget reasons? Oh yeah, okay. You want to move your prototype around in the open on a freaking lowboy trailer? That thing's a mock-up. That's not real. that's not real. Oh my goodness. That ain't real. Look at the landing gear, man. There's no way this is flight fidelity. Are you kidding me? That looks like it belongs on a rickshaw. A wind tunnel model? What? This ain't no new helicopter, man. This is a movie prop. The radar test article. What I'm trying to tell you is that, okay, China's a lot of things, but they can make it better than that. A radar test article, a structural testing article, any type of test article wouldn't look like somebody painted it with paper mache, okay? Right? They're a little bit better at engineering than that. Come on. Sure, if it's made of paper and wood, it'll be real good at blocking radar. Oh my goodness. What do you mean new Chinese helicopter? No way. Not a chance. Yeah, maybe, John, right? Ooh, here's a good trivia question. Why does that one have a cover on it and that one doesn't? Who knows? I know the reason. Do you guys know the reason? Why does this hold down point have a cover over it and the other one doesn't? What is this? The SSMEs are above it? They're pointed in another direction. Oh, Jesus. Nope. Yep. Okay. Back. Jeez. Data lines. Nope. Well, why doesn't this hold down point have a cover on it? Why does that one have a cover on it? Let me rephrase. Why is the flame on this camera so you can't see anything, but you can still see something over here? I wonder. Because they wanted to science the heck out of it. Because the shuttle slews off the pad. There you go, Urban Burger. I saw somebody else say it too, but yep, you got it. There you go. Shuttle slews off the pad. Somebody said shuttle main engines. Shuttle main engines, because they're pointed this way, they make the shuttle go this way when it flies off the pad. It flies kind of sideways off the pad. So the SRB exhaust ends up going this way. And that's why they needed a cover on one and not the other. Really awesome camera, by the way. Here, there's another shot where we can show you. This one right here. Watch this. Watch it move. See? There's the cover. This should show you a little bit more why you need the cover. My mouse cursor is where the cover is. Where that hold down point is. Uh-oh. Yeah, it needs the cover because the flames is not gonna do good. Detective, there's no going in there. You tell me two things. I don't run. See? Shuttle's moving off the pad. Sideways. Goes this way a little bit. Made the satellite carrier things that the shuttle had. Oh, very nice. Oh, that looks real good. Snackless, you did a good job. Yeah, it's a little... See, look where the SRB is. It's over here somewhere. Big Starlink modifications. Generation 2 amendment. All right, well, we're out of time for space news. We can keep watching. We can watch the shuttle footage some other time. We got an SSTO to launch. Let's do it. What is this last thing, Forge? The satellites will be somewhat larger and generate more power, enabling them to support expanded capabilities now and accommodate additional payloads in the future. The Gen 2 satellites will have enhanced reliability by building upon the design